For 4 and 5, the square root of 5 over the square root of 2. So I'm going to split these. And this is where you guys want to make that perfect square in the bottom. So we're going to make a perfect square of 4, but you can't just do it to the denominator. You have to multiply the fraction by a value equivalent to 1. So we have to do the top and bottom. So what happens is you get the square root of 10 over the square root of 4, and that square root should be a perfect square now in the bottom. And then you guys are done. It's rationalized when you have no radicals left in the denominator. So why don't we look at number 6? So 3 times 7 plus square root of 2. So we can't just multiply by the square root of 2. Yes, that would take care of this and make 2, but then we would have 7 square root 2 left because that 2 goes to both. So that's why we have to multiply by the conjugate. So the conjugate would be, it's originally 7 plus square root 2. The conjugate would be 7 minus square root 2. Have to do it to the top and bottom. So on the top, that 3 would go over there to both of them. So 3 times 7, 21. 3 minus square root, or 3 times negative square root 2. 3 square root 2. So on the bottom, if you guys really want to, we could do a generic rectangle. We can do it for the first time just to kind of show you guys what happens. So if you guys did 7 and positive square root 2, and 7 minus, 7 times 7, 49, negative 7 square root 2, positive 7 square root 2, negative square root 4. So what happens is the positive 7 and that negative 7 square root 2 cancel each other out. And that's what's supposed to happen with the conjugate. That's the idea. And this value here just simply becomes negative 2. So the whole bottom of this fraction becomes 49 minus 2. So we get 21 minus 3 square root 2 over 47. You do always want to check and make sure that those 3 coefficients, those constants, can't be reduced by anything, but they can't. Nothing goes into 21, 3, and 47, so you guys are good. That is in simplest form. There's no roots or radicals left in our denominator. So why don't you guys try 5 and 7?